Okay, 7th grade. We worked on proportions a little bit before CSAP, so this might be familiar to you guys. The vocabulary word is proportion, and this is on page, since you're following along in your book, this is page 418 in your book. So make sure you're looking with me. A proportion is two ratios that are equal, okay? Set equal to each other. And one of the things that a proportion, and it's right here, a proportion is an equation that states that two ratios are equivalent. So why don't you go ahead, it's kind of a double whammy here. Go ahead and write this key concept box. It is on page 418 right at the very top, and I will put some numbers in for it. So this would be a proportion. 3/5 equals 6/10. Those fractions are equal to each other. So one way it says it's read is 3 is to 5 as 6 is to 10. So 3 times 2 makes 6, 5 times 2 makes 10. So they are related to each other. Algebraically, A over B equals C over D, where B and D are not 0. You can never have a 0 on the bottom of a fraction. You never can divide by 0 since fractions are division. So let's take a look at some proportions. A person burned about 210 calories while inline skating for 30 minutes. About how many calories would the person burn while inline skating for 60 minutes? In example 1, you will use a proportion to answer this question. So let's just do it. 210 in 30 minutes, so I would write it 210 in 30 minutes. And over here I usually put a little mark. This is calories and this is minutes. So I want to know how many calories, which is unknown, so X, would I burn in 60 minutes? So you look at that, it's pretty easy to solve because 30 times 2 is 60. So 210 times 2, would be 420. So you would burn 420 calories. Here's the setup. And it's the same thing right there. They take forever to solve it, don't they? So solving this proportion, you look at from 10 to 25 on this guided, I don't know if this is a guided practice or the example number 2. Oh, it's example number 2. So you look at this, and what we were doing last, in the last chapter when we were solving, really we're solving this, and we have an unknown. We want to get X by itself. So if I say that out loud, that's X divided by 25. So what's the opposite of dividing by 25? Would be to multiply by 25. So you could do that to both sides. Put this over 1. Cancel. 5 goes into 10 2 times. 5 goes in there 5 times. So it'd be 30 over 2, which is 15. So one way is to incorporate the algebraic solving that we were doing back in chapter 7. Let's see if they solved it the same way. They did. Multiply each side by 25, and then you simplify that out. They didn't cancel first, so use equivalent ratios to solve the proportion. So you look at this and you go, hey, what do I do to 5 to get 20? Well, 5 times 4, so 1 times 4, so Z is 4. Here you say, what do I do to 3 to get 18? 3 times 6, so 8 times 3 would be 48. This one you can go backwards. You can look at it this way. I can find my pin. You can look at it this way. 9 times 3 is 27, so 12 times 3 would be 36. 9 times 11, it's almost a practice in multiplication facts, isn't it? So what times 11 is 22, so this one would be 2. Use algebra to solve the proportion. Well, this one you can't, there's nothing times 14 that'll get 49, so you do what we just did. You get the m by itself. This is m divided by 49. The opposite of dividing by 49 is to multiply by 49. And let's see, 14 and 49 I don't think cancel, so you do 49 times 4. 16, that'd be 196 over 14. And all I'm doing is top times top, bottom times bottom up here on this fraction. 14 into 196 goes once, which is 14. 56. What's 14 times 4? Look at that, is 56. Oh, it does. It goes in there. So M equals 14. And same thing on the next, algebra to solve it. Let me get the marker off. X divided by 12, the opposite of dividing is multiplying. So I multiply this side by 12. That's 12 over 1. 6 goes into 12 2 times. 6 goes into 35 times. 2 times 25 is 50 over 5. So X equals 10. So again, we're using algebra. So H, we find that side, H divided by 33. So times 33 to cancel those out. Times by 33 over 1. 3 goes into both of those. Goes in there twice. Goes in there 11 times. 2 over 2 is just 1. So H is 11. And then times 8 to make that cancel out. Times 8 over here. 4 goes into 8 2 times, 4 goes into 28 7 times, the 7's cancel out, leaving you just 2. Alright, so example number 3, doing some more story problems with this. It says, the elevators at the Empire State Building can pass 80 floors in 45 seconds. Follow the steps below to find the number of floors that the elevator can pass in 9 seconds. Well, the first thing I would do is I would write an equation, or write a proportion. So I write a blank proportion, so I write it like this. And the first thing is I write what goes together, 80 floors in 45 seconds. So I write that on top of each other. I label this floors and I label this seconds. How many elevators can pass in 9 seconds? Now 9 can't go on the top because we have floors on the top. So 9 goes here and this is an X. And I see that's pretty friendly. 9 times 5 is 45. So what times 5 is 80? And I believe it's 16. So you can do 16 floors in 80 seconds. So let's see how they do it. They write the proportion, same way. They solve it. Oh, they're doing it the algebra way, which I wouldn't do unless you absolutely had to. We should get the same answer. Yep, we do. So it says, suppose the elevators in example 3 could pass 70 floors in 63 seconds. So we write our blank proportion, 70 and 63. This is floors, this is seconds. How much could that do in 9 seconds? This is still easy because 9 times 7 is 63. So what times 7 is 70? That's easy, 10. So you could go 10 floors in 9 seconds at that rate. All right, so we're writing those proportions. Just make sure you put the numbers in the right place, and you're either solving them mentally, you can see it right away, or you can use algebra this time. And we'll see you next time. Show your work.